Hey guys, we're going over section 7.3. Going to look at some more identities that we've taught that we're going to add on to the ones we already know, because we already know the Pythagorean identities, we know the quotient identities, and we know the reciprocal identities. So we're going to add on another identity, which is the sum and difference identities, which are actually three parts to that, just like there were like three parts for the Pythagorean identity. For the sum and difference identities, there's actually going to be three parts of it. So we're going to start off with one of them. So we're going to start off with cosine. We're going to the cosine of the sum and difference identities. We have cosine A plus B, and we have cosine A minus B. Cosine A plus B being the sum, because you're adding. Cosine A minus B being the difference, because you're subtracting. So therefore the difference in sum, or the sum and difference. With this, we're looking at, right, for the sum itself, we're adding. So when it comes to these, we're actually going to be dealing with like more than one trig function here. So with this, we're going to take a look at our signs. If it's the as sum part here, the plus, what's going to happen is it's going to change signs in the middle here. So if it's a plus, it's going to change signs in the middle. For a negative, if it's a negative or a minus, it's going to change signs when it comes to the inside there to a plus. So if you kind of remember that C for cosine means like C for change, like change in sign, then that'll help you out a little bit to remember it. So for remember again, cosine, the change in signs. Also for cosines, the cosines are together here, the sines are together here. So cosines together, signs together. And the only thing that changes is just that sign in the middle. So, one of those things you gotta remember. Right, so, let's go on to example 1 here. Let's take a look at some work dealing with the sum and difference identities for cosine. So first, we have example 1. It says, show by producing a counterexample that x minus y is not equal to cosine x minus cosine y. So in other words, what they're giving you is cosine x minus y equals cosine x minus cosine y. They're giving you this, and they want you to show by a counterexample that this is not true. So they're giving you this, and we need to prove this part right here. So we need to go back to our table that we've talked about many times already, and we've used many times, and also that we know the values on already. We're going to go back to that table, and we're going to use some radian values. You can also use degree measurements also, but we're going to use radians for this one. We're going to let x equals a value, and we're going to let y equal a value. And just for me, I'm going to use power for 4, and power for 4 again for y. So power for 4 for x, power for 4 for y. Now, with each one of these can actually be different values. They could be the same values, and anything that you want to use really that will make this be a counterexample. So that this side will not equal that side at all. So let's go and substitute this in and check it out and see if it does equally so. If it does equal, or if it makes it a counterexample. So we're going to substitute pi for 4 in for cosine x, and another one pi for 4 for y. And we're going to check it into this side here. So we do cosine pi over 4 again for x minus cosine pi over 4 for y. Alright, so then we find our values here. For 1 on the left side, cosine, we have pi over 4 minus pi over 4. It gives you cosine of 0. That's pretty easy. Alright, so here we have cosine pi over 4 minus cosine pi over 4. And we're going to just go and simplify everything using the values from our chart. So cosine of 0 is at 1. Cosine of pi over 4 is square root of 2 over 2. And cosine of pi over 4 is square root of 2 over 2 again. So we're looking at 1 minus square root of 2 over 2 minus square root of 2 over 2. Which means 1 equals square root of 2 over 2 minus square root of 2 over 2. So then we go ahead and check and see if these two sides are equal to each other. So this side here we already know That's a 0. We had a 1 on the left side. So those are not equal to each other. So we just found a counterexample that shows that cosine x minus y does not equal cosine x minus cosine y. So that's not an identity. That will never work. So the second part of this question says, show that the difference identity for cosine is true for the values used in part A. So for those values that we use for cosine x equaling pi over 4 and cosine y being pi over 4, we're going to check that and actually put it into the difference identity for cosine and see if it actually is true, like we said it is, like as an identity. So, looking at cosine x minus y, that will equal cosine x cosine y. And because there's a minus here, we do the opposite sign, or we change the sign. It's a plus there. So this is sine x sine y. So now we're going to go ahead and use our values. We said that x was equal to pi over 4. We say y is equal to pi over 4 again. And we're going to check just to make sure they equal each other. So we do cosine pi over 4 minus pi over 4 here. And that will equal cosine pi over 4 again. Times cosine pi over 4 plus sine pi over 4 times sine pi over 4. So let's go ahead and work this out and finish it up. So here we have cosine, once again 0, which we did on the one above this in A. For these, we have square root of 2 over 2 times square root of 2 over 2 plus square root of 2 over 2 for sine pi over 4 times square root of 2 over 2 for sine pi over 4 again. And we're going to simplify everything down. Cosine of 0 is 1. And we set at the top. Square root of 2 times square root of 2 is 2 over 2 times 2, which is 4, plus square root of 2 times square root of 2 is 2. 2 times 2 is 4. So it's going to finish this up. X is 1 equals 4 over 4, which is 1 equals 1. And we have just proven it. That's true for these values. Alright, see you for example 2.